Hello, I'm doing this video to talk about the electronic configuration, which is how the electrons are arranged on the different energy levels and the different sublevels. I hope you remember that the energy levels are the different layers that are surrounding the nucleus of the atom. So, if you remember, we have this, which is the nucleus of the atom, and then surrounding the nucleus we have the first layer in which we can put 2 electrons, and then the second layer in which we can put 8 electrons. Okay, and then we have different sublevels that have different names. So the first one is called S, the second one P, the third one D, and the last one F. And you can learn different sentences to remember the order, but the order is always S, P, D, and F. And in each one of these sublevels we can put different electrons. So on the first sublevel, on sublevel S, we can put 2 electrons. On sublevel P we can put 6 electrons. On sublevel D we can put 10 electrons, and on sublevel F 14 electrons. And we always write it like this: S2, P6, D10, and F14. We have something that is called diagonal rule, or we can call it Moeller's diagram, which is like a diagram that we use to know which order we have to follow to place the different electrons. So in this diagram we have in here the different levels, starting with level 1 until level 7, and then on this side here we have the different sublevels. So on the first level we have sublevel S. On the first sublevel we only have one sublevel. On the second level we have 2 sublevels, S and P. On level 3 we have 3 sublevels, S, P, and D. On level 4 we have 4 sublevels, S, P, D, and F. On level 5 we have also 4 sublevels, S, P, D, and F. And then on the next levels we always have 4 sublevels, which is the maximum. Also, these red arrows, they tell us the order that we need to follow. So you need to know the order that you need to place the different electrons. So you always start with this one, you follow this line, then you move to the second line, then to the third line, and then to the fourth line. But the numbers that you need to look are these ones. And I'm going to put an example because it is easy to understand with an example. If I ask you the electronic configuration of oxygen and I tell you that oxygen has an atomic number of 8, remember that this letter means atomic number. So if the oxygen has an atomic number of 8, you know that the atomic number is the same as the protons. It means that it has 8 protons. So if the charge is 0 and you know that you have 8 protons, it means that the electrons are 8, because if you have 8 protons and the charge is 0, which number do you have to put here? 8. So you have 8 electrons, okay? So to do the electronic configuration of 8 electrons, you have to start on this line and you have to follow this line. Which is the first letter that you see here? The letter S. And letter S is in which level? In level 1. Okay, so the electronic configuration of oxygen is going to start with 1S. 1S because the first letter that you see is S and it is on level 1. Okay, and then you have to look on level S, on sublevel S, how many electrons can I put? 2. I can put 2 electrons. So I'm going to come here and put 2 electrons. Okay, so I have to put 8 electrons and I already put 2. So I need to continue. And I'm going to the second line and I find this letter S, which is on level 2, so 2S. So I'm going to come here and put 2S and also 2, because we know that on the S we always can put 2 electrons. If I have to put 8 electrons and I already put 2 plus 2, 4 electrons, I still have to put 4 more electrons. So I'm going to continue on the third line, and on the third line I find this letter P, which is on level 1. So on level 2. So I'm going to put 2P. Okay, and how many electrons can I put on P? 6 electrons, but I don't need to put all of the electrons because I already put 2 plus 2, 4 electrons, and I have to put 8 in total, so I only need to put here number 4. And with this, I put 8 electrons. On the second example, they also give me oxygen, and I know that it has an atomic number of 8. It means that it has 8 protons, but in this case they tell me that this oxygen has a negative charge of 2. So it means that if I have 8 protons, I don't know the electrons, and I know that the charge is -2, I need 10 electrons. Okay, so in this case I need 10 electrons. And I'm going to start like I did in the last exercise. I'm going to go to the first line, S, so 1s, so I'm going here and I put 1s, 2. I need to continue. Second line, again S, 2s, and 2s to the power of 2. Why do we know that this is 2? Again, because you have to know this. You have to learn these numbers, okay? So I put 2 plus 2, 4 electrons, but I have to put 10, so I need to continue. Third line, and I find this letter P, which is on level 2, so 2p6, and if I add both the three numbers, I see that I have 6 plus 2 plus 2, 10 electrons, so I put my 10 electrons. So I finish with this example. Okay, let's go to the third example. In this case, they tell me that I have this -3, this is bromo, and then they tell me the atomic number, which is 35. This means that I have 35 protons, and if the charge is -3, I need 38 electrons. Why? Remember that if you have 35 protons minus 38 electrons, the charge is going to be -3. So I'm going to have 38 electrons, and I'm going to start as I did on the previous examples. So first letter S, 1s2. Second line, this letter S again, so 2s2. I need to continue. Third letter P, okay, so 2p6. And if you remember from the previous example, so far we put 10 electrons, and I have to put 38, so I need to continue. I'm going to go on the next letter. I already did this, and I need to continue through this line, so I'm finding this letter, which is S, and it is on level 3, so 3s. 3s2. Okay, and I need to continue finding the rest of the electrons. I completed this line, so now I have to go to the next one, and I find this letter P, and it is on level 3, so 3p6. Okay, and so far we put 2, 4 electrons, 10 electrons, 12, and 18, but I need to put 38, so I have to continue. Okay, after 3p, if I follow the line, I find this letter 4s, so 4s2, and I still need to continue. Over here, D, 3d, and on D I can put 10 electrons, so 3d10. But I need to prove every time that I have to continue, because I have to test now if I put all of the electrons. 2 plus 2, 4, plus 6, 10, 12, 18, 20, and 30. So I have to put just 8 more electrons. And if I was in this letter and I continue the line, I find this letter now, so 4p. Okay, 4p6. Okay, so I'm only missing 2 more electrons, and I continue with the line, this one, S5, S2. So now I finish with my 38 electrons. it doesn't matter if you put her here first 4 and then 3 and then 4 again, it doesn't matter, okay? You have to always look at the lines to know the order. In the periodic table of the elements, we have different groups and different periods. The groups are the columns and the periods are the rows. Okay, and we're going to see something now that you also have to learn, which is that on the periodic table of elements we have different groups, the columns, and different periods, the rows, and then you have to know these things that I put here on red, which is that all of the atoms on this column, their electronic configuration finish with S1, the atoms on this column, they finish with S2, and these ones, they finish with D1, D2, D3, D4, D5, D6, D7, D8, D9, and D10. And these ones over here, the column 13, they finish with S2P1, column 14, S2P2, column 15, S2P3, column 16, S2P4, column 17, S2P5, and the last column, which we call the column of the noble gases, because all of them here are noble gases. Why? Because they finish with S2P6. This means that they have 8 electrons on the last layer, and this we're going to see later that is very important. Okay, so in this case, if I, instead of giving you the number of electrons, I give you the electronic configuration, so you already have the electronic configuration, and I ask you, which element is this one? Which element is this one if it has an electronic configuration of 1s2 and 2s2? Okay, you have to know that the last number that you see here is going to be the row, and these numbers here, the letter and the number, is going to be the column. Okay, so this means that we are in the second row, so not this one, we are in this one, the second row. So it could be lithium, it could be beryllium, it could be boron, carbon, nitrogen, oxygen, it could be any one of the elements on this row. But it finished with S2, so the only column that finished with S2 is this one, the second column. So we know that if we are in the second row and second column, it must be beryllium. Okay, so this is going to be beryllium. Okay, and then this one here, if I give you this electronic configuration, you also have to look. It finished with 2, and the letters, it finished with S2, P5. Okay, so this 2 means that it is on the second row, and these letters means that it finished with S2P5, so S2P5 is only this column. So, okay, it is on column 17, second row. So column 17, second row is this, fluor. So this one has to be fluor. And finally, what happens if they give you this? So they give you this electronic configuration, but you see here that it has a minus. This minus means that it has a negative charge of 1. It has a negative charge of 1. If in here you had a 2 instead of 1, if it was 2 minus, this would mean that it would have a negative charge of 2. But if you only have a minus and nothing else, you have to know that a minus is always 1. So this means that it is a negative ion, or we can also call it an anion, and it is negative, so it has more electrons than usual, more electrons than protons. So in this case it has one more electron than usual, So the normal atom, it would be with one less electron. You see here that I change from 6 to 5. Why? Because this one here has one more electron, and if we want to know the normal one, it has one less electron. Okay, so now you have to look at the last number, and the last number is 3s2, 3p5. So it's going to be row 3 and column S2P5. Okay, so row 3 is this one and column S2P5 is this one. So row 3 column 17 is going to be this chlorum. So you know now that this is chlorum. This element is chlorum. Okay, I hope you understand the things that I explained, and also remember to do the exercises that we did in class and practice.